Hello there. Welcome to Chapter 4. Today we're going to look at antiderivatives and the indefinite integral. So we've been playing with functions that look something like this. A function could be x cubed plus 3. Well, when I go ahead and take the derivative of that will be 3x. This guy is called, by the way, a differential equation. I will say differential equation. So differential equations, there's a whole actual college class that is designed for differential equations. This is not it. All right. So I just wanted to let you know that this f prime of x is called a differential equation. Nice. Now, next slide, please. I don't know where I'm at, so here we go. All right, we're going to talk some notation. The opposite of differentiation is called anti-differentiation, and that gives us the indefinite integral, or integration. This is an integral sign. So when you look at Chapter 4, you'll see this little squiggly s. Well, that's an integral sign. So it's going to be the integral of f of x dx. And let me tell you what all this means. This means this is called the integrand. This is called the variable of integration. Once again, it's going to tell me what variable I'm integrating with respect to, because we can have many variables, as you know. We're going to integrate with respect to x. So this is going to be dx. When I do that, I get capital F of x plus c. This c is the constant of integration, because remember, in the last example, when I take the derivative of this, where does that go? It goes to 0. So to get it back, we don't know what it was. It could have been anything. So we put plus c. And this is called the antiderivative with respect to x. This is the indefinite integral. Indefinite means you're not going to get a number answer. You're going to get an expression. So this is, if I do the integral of f prime of x dx with respect to x, I get the original back. They're inverse operations. Everything in math, you know, are inverses. You have operations of derivatives, operations of antiderivatives. So integration is actually the reverse of differentiation. That's all I'm saying here. That's it. So we did 3-4 slides in about a minute. Really loud in here. Basic integration rules. If you take the integral of 0, you get an answer. C. If you take the integral of x, you get 1. I don't think that's written here, so I'm going to do it. The integral of x, you get 1. I should really put it nice. It's the first time you're seeing it. So you would see the integral dx. Oh, come on. The integral of x dx equals 1. No, it doesn't. My bad. It doesn't equal 1. Sorry. Okay. The integral of 1 dx equals x. I think. I don't know. Yeah, that's right. Sometimes the 1 isn't shown, so sometimes you would see the integral of just dx. The 1 is understood. Okay? Then you got the sum of the integrals is the integral of the sums. You got constants. If you take the integral of a constant, you get the constant times x. That's exactly what I did here with the 1. The 1 is a constant, so I got 1 times x plus c, actually, if you want me to be right. And then the integral of a constant times a function, you can bring the constant out of the integral, all right? And here is your reverse power rule. If you remember the original power rule, it was subtract 1 from x and divide by it, but now we're going to add 1 to x and divide by it, and divide by n plus 1. And n can't equal negative 1. So if I have this, it's a totally different integral. We won't be doing any like that right now. This natural log. All right. Anyway, so let's do some examples. I think that's the best thing to do. Let me get my papers ready, and let's roll. Let us roll. So, first example. the integral of 3x dx. Well, 3 is a constant. I'll bring that out. I don't have to, and I'll get this. Do my inverse thing, add 1 to x and divide by it. So I get this plus c. Makes sense. By the way, if you did 3 times x squared over 2 plus c, and you went ahead and multiplied that, it doesn't matter. A constant times a number is a constant. All right? Or you could just use 3x. Don't even do this. And take 3x and say, this is 3x squared over 2 plus c. You're getting the same answer no matter how you slice it. All right? Let's do another example. Do an example of the integral of x plus 2 dx. That's going to be equal to, well, I'm going to use that sum thing, the integral of x plus 2, the integral of 2. All right, the integral of x is x squared over 2, plus 2 is going to be just 2x plus c. Answer right here. I don't know if I'd show this. I might do it all in one shot and just say this is x squared over 2 plus 2x. This is going to be done quickly, just like the derivatives were. And you have to know them like the back of your hand. Let's do one more. I don't know if I'm getting too crazy because we're just saying it for the first time. 3x to the 4th minus 5x squared plus x all dx. Okay? And now I'm going to get the integral. 3x to the 4th is 3x to the 5th over 5. Add 1 to the power, divide by that power. Minus 5x to the 3rd over 3 plus x squared over 2 plus c. So I do each one separately. Any questions? People usually like this. Kids usually like this. All right? So that is one part of what we need to know about integration. Then we start with part 2, which is initial conditions and particular solutions. I said y equals f of x for a value of x is initial condition, and we're going to solve it for that particular solution. So now we're going to start to get number answers, okay? Give me a second. Just moving my notes here. All right? So here's an example on the bottom here. If f of 2 is equal to negative 4, or capital F of 2 is equal to negative 4, find the solution of this. And the first thing we're going to do is integrate it. So I'm going to get x to the 4th over 4, and the 4 will divide out, plus x squared plus c. Remember, this would be 2x squared over 2. And 2's go out. I know something. I know that when I plug in 2 for x, this is what this means. When I plug in 2, I get negative 4. So we're actually going to solve for c. Okay? So this equals negative 4. So when I solve for c, I get c equals negative 24. So our particular solution is x to the 4th plus x squared minus 24 for that problem. That minus 24 replaces the c up there. It's easy as that. I know you're waiting for this, and maybe this is for you. I don't know. But you know there's going to be some trig involved. So let's get to some trig to show you. Sine over cosine squared. Okay? Well, what I'm going to do is I'm going to say that this is equivalent to that. Tangent secant x. This is a special integral. Tangent secant x turns out to be just secant x plus c. Because if you remember, let's go the other way. If you took the derivative of secant, it's secant tangent. So now going the other way, you just get secant. Nice. I hope. There's a list of these, and it's the exact opposite of what the derivatives were, just going the other way. Let's do this problem. We got t squared plus sine of t. Well, when we integrate, t squared becomes t3 over 3. When we integrate the sine, we get negative cosine t. So remember, if we took the derivative of negative cosine, we get sine. So when you take this of sine, this equals negative cosine. So it's the opposite of what you did for the derivative. And this is plus c. Done. So if you know the derivatives, you'll know this stuff. All right, I would like you to try some stuff for homework. Let's try some problems. Let's try on I don't know the page. It's 4.1, okay? So find 4.1. I don't have the page number here. I apologize. I'm looking feverishly, but I don't have it. 4.1, you're going to try number 12. You're going to try number, why don't we try 24, 22, 28, and 30. Why don't we try those? I got to mark them. Okay. So we're going to try 12, 24, 22, 28, and 30. I know they're out of order, but that's just me looking at stuff. I want to see, is there anything else? No, that's it. Antiderivative. The opposite of derivatives. It's called the integral. The indefinite integral. You don't get any number answers unless you're looking for a particular solution. Okay? See you tomorrow. I'm back. Sorry about that. It's on page 255. All right? This is on page 255. All right. See you tomorrow.